Welcome. This is Mrs. O'Brien, and this is the first video I'm making for the year. It's going to be a quick review of factoring. My goal is to kind of get the rust off of you, and after that, tomorrow we'll do an activity in class with lots of factoring, and some will be very challenging. Before you start this video, if you're logged into Edpuzzle would be helpful. Now, if you have trouble being logged in, don't worry. All the kinks will get out. But if you can have it logged in while you do this video, at the end there'll be a couple of questions for you to answer that I can check and see how you did. With that said, we are now going to start our review of factoring. In the past, you've learned several methods, including greatest common factor, difference of two perfect squares, your basic trinomial factoring when there's a leading coefficient of 1, and regrouping. With that said, the first example that I'd like to do is the following question. 10a cubed b minus 15a squared b squared. What I'd like you to do is just turn off this video, try to factor this in your notebook, and then turn it on and we'll go through it together. So how'd it go? Hopefully you recognize this as a greatest common factor method. The 10 and 15 have a GCF of 5. The a cubed and a squared have a common factor of a squared. How I usually think of this is I say a is common to both of them, and what's the greatest number of a's they both have in common. Again, the b and the b squared are common to both terms, but the most b's they both have is 1. At this point, I'm going to think to myself, what do I multiply 5a squared b by to get 10a cubed b? And after careful consideration, I'm thinking 2a. And then I say to myself, what do I multiply 5a squared b by to get 15a squared b squared? Well, 5 times the negative 3 will give us the negative 15. A squared is already a squared, so I'm going to need to multiply the b by b to get b squared. Again, just check yourself by doing a quick distributive property, and I'll see I have 10a cubed b minus 15a squared b squared. Awesome. Now let's go to example 2. For example 2, I'd like you to factor 4a squared minus z squared. Again, turn off the video and do a quick tutoring. A quick factoring. Here we go. If we look at this, we can factor this by the method of difference of two perfect squares. 4a squared we can think of as 2a times 2a, z squared as z times z. And with the difference of two perfect squares, one sign is positive, the other is negative. And this, we can really see why we need this when we look at the outers and the inners. In order for them to cancel, or what I always call the OI to cancel, we need them to be opposite signs. For example 3, I would like you to just try to factor x squared plus 2x minus 15. Again, just turn the video off and give it a shot. This is what I mean by my basic trinomial. Usually we, in our mind, recognize to get the x squared, we're going to need an x times an x. To get the negative 15, we need the last two terms to multiply to negative 15, but we need them to add to positive 2. Thinking about that, I know 5 times 3 will give us 15, and that if I make the 5 positive and the 3 negative, I'll end up with the inners being positive 5x and the outers being negative 3x, which when I add them together will give me the 2x. The next example, which will be our example 4, I'm going to ask you to factor 15 x squared minus 16x plus 4. Good luck. Now, when you look at this one, you should recognize that it almost looks like our basic trinomial, except there's a leading coefficient of 15. Now, unless I can first pull out a GCF, I'm thinking that I'm going to have to regroup. Usually when I regroup, I think of 15 times 4 is 60, and I say, what are the factors of 60 which would add up in some way to negative 16? And I'm thinking to myself, negative 10 times negative 6 will give us positive 60 and add up to negative 16. So when I regroup, I'm going to think of this as 15x squared. Then I'm going to think of it as minus 10x minus 6x plus 4. At this point, for the first two terms, I'm going to factor out a 5x, which is going to leave me with 3x minus 2. For the second term, I'm looking over here and I'm thinking I can factor out a negative 2. And then I would need negative 2 times 3x minus 2. Careful noting that a negative times a negative would give us a positive 4. The beauty of this is, if I look at this closely, excuse me there, both of these terms have a common factor of 3x minus 2. So I can factor out the 3x minus 2, and then I would have to multiply it by the 5x minus 2. So putting that all together, by doing this with a regrouping method, I would end up with 3x minus 2 times 5x minus 2. For our last example together, we're going to try, or have you try, 3x to the 6th minus 48x squared. Again, I want you to turn the video off and just give it a quick try factoring. What's different about this one is that you're using a combination of methods. The first thing you should notice that there's a GCF. We can factor out a 3x squared. If I do that, I can have in parentheses x to the 4th minus 16. Oh, but bells are going off. X to the 4th minus 16 is the difference of two perfect squares. So I can factor that as x squared plus 4 times x squared minus 4. And then bells go off again because I notice x squared minus 4 is also the difference of two perfect squares. So I can take that x squared minus 4, factored into x plus 2, x minus 2, and then I'll have the last factor, which is x squared plus 4. Now, like I said, tomorrow you're going to have some challenging problems mixed in with some easier ones in a class activity. If you're on Edpuzzle now and you're watching this video, you're going to see some problems pop up. I'm going to ask you just to factor the 2-3 problems, submit your answers. Just kind of a note, if you have to use something to a power, so you had something like x squared, you can input that as x caret 2, and it should look like an x squared. Anyhow, give those a try, and hopefully this kind of got the rust off of you, and you'll have some fun trying some of the other problems.